Okay, so the first one we talked about was binomial. Okay, the way we know it's a binomial distribution is that we have a fixed number of trials. And that's our n. Okay. And our x value here, the random variable, equals the number of successes. Ooh, if I can spell, it's helpful. Okay, the number of successes. Right, that's what makes binomial binomial. Okay, there's the probability of success and the probability of failure, independent trials, but those are all the same as geometric. Okay, geometric, we have no n. We have no fixed number of trials. It could be infinitely many trials. But our x value equals the first success. Okay. Both of these have independent events. And the probability of success is the same. Okay. That's what they have in common, but you really need to make sure you understand the differences between the two. Okay. And then Poisson, okay, we don't have an n value, but instead what makes it special is we have some type of average or mean. Okay, so that's like the keyword you're looking for in the problem. Okay, and then your x value is you're just going to equal, it's not really the number of successes, but we'll say the number of successes. Okay. So that's what makes it special. Okay. Then we have our formulas, which yes, those are all different, but if I ask you the difference between something, I don't want the answer formulas. Okay. So remember binomial, the probability of x equals n combination x times p to the x power times q to the n minus x power. Geometric is similar, but no combination. So it's just the probability of success times q to the x minus 1 power, because you have one success and everything else is a fail. And then Poisson is super special. And I'm going to be honest, I can't remember which order it comes in because I normally use the table. Let's see here. Mu to the x power, e to the negative mu. I don't think that's right. And what's in the denominator? Is it x factorial? Okay.
Yeah, that's correct.
That's correct. Okay. But then Poisson has a table that we can use, which makes it nice and easy. Okay. And then which other one has a table? Binomial. But when can it be used? It's only when p is what? It's only when p is a nice number. Okay. Not always available. Okay. So it's only when p is either 0.01 or something with an increment of 5. So 0.05, 0.1, 0.15, 0.20, and continuing up to 0.95. Right? Okay, so we're going to look at 3 examples, and we're going to determine which of the distributions we're using. Okay? All right, so look at this first one. 82% of people using electronic cigarettes are ex-smokers of conventional cigarettes. You randomly select 10 people. Find the probability that the first person, which is an ex-smoker of conventional cigarettes, is the second person selected, the fourth or fifth person selected, and C, not one of the second through seventh. So which distribution is that? I heard binomial. Why binomial? Okay, so we have a fixed number. N equals 10. Okay. And then you would do part A, B, and C. Okay. On your test tomorrow, if you pick the wrong one, but you do your work to follow that, you're going to miss part A, but you're going to get B, C, and D correct. Because I'll keep going with what you chose. Does that make sense? Okay. All right, let's look at the second one. During a 10-year period, sharks killed an average of 6.1 people per year worldwide. Find the probability that the number of people killed by sharks next year is exactly 3, more than 6, or at most 5. Poisson, why? There's an average. Mu equals 6.1. Also, there's no probability of success. Okay, there's no percentage. There's no decimal you could come up with. Okay, that's less than 1. So that's an easy way to tell. Then 3, 36% of Americans think there is still a need for the practice of changing their clocks for daylight savings time. You randomly select 7 Americans. Find the probability that the number of Americans who say there is still a need for changing their clocks is exactly 4, less than 2, or at least 6. What would that be? Binomial. Why? All right, so fixed number of trials. N equals 7. Okay. So there is one of these 3 problems we could change to make geometric. So let's talk about that. So the first one, if we get rid of something, we can change that to be geometric. What would you get rid of? If you get rid of this, you randomly select 10 people. And the reason why it says find the probability that the first person, okay, that first success is the second person, the fourth or fifth, not one of the second through seventh. That changes it to be geometric. Okay. So if you were to remove the N, the fixed number of trials, it becomes geometric because of the word first person. Okay, meaning the first success is whichever trial. Okay.